Alright, Algebra 1, Common Core Algebra 1, we are on our last lesson on solving systems of equations, and so we've talked about graphing and we've talked about substitution, and now we're going to do our last way that we're going to solve with something called elimination. Okay, and so the basic idea of elimination is that we're going to eliminate one variable and solve the other equation, kind of like substitution. So, solving a system of equations by elimination, your first step is that we need to create opposite coefficients. So we want to create opposite coefficients, and we're going to do that by multiplying one or both equations by a number that will create those opposite coefficients. Okay, and we'll talk about what that means in a minute. After we create those opposite coefficients, we're going to add the resulting equations together, and what that should do is create only one remaining variable. So after we add the resulting equations, you should have one equation with one variable. Okay, and then we can solve for that only remaining variable, and after we do that, so that'll give us one variable, either x or y. We need to take that value and substitute it into either original equation and solve for the remaining variable. Now, in reality, it doesn't have to be one of the original equations. It can be one of the equations you created in step 1, but it's probably going to be easiest just to take that value, substitute it in the original equation, and solve for your remaining variable. So remember, our solution is going to be some point x comma y. Okay, that point of intersection when we were talking about graphing or substitution, we had a solution that was x comma y as well. So what does it mean to have opposite coefficients? Well, that means they have the same number in front of the variable. Like the number in front of the variable is called our coefficient. Either the number in front of x or the number in front of y is the same number, except opposite signs. So one positive and one negative. Okay, so an example of creating opposite coefficients, this is oftentimes where we have the most trouble. You can choose either variable. In this example I said, let's choose for x. So we want these two variables, these two x's, to have opposite signs. So I need to multiply the whole equation, each of them, by a number. Okay, in the first one, in this example, one thing we can do is say we can get them both to be 6. Now, that's one way to do it, or an easier way that always is going to work is just take the coefficient of x down here, put it in front of the first one, the coefficient of x in the first one, put it in front of the second one, except we also need to switch that sign, so make it a negative 6. Now we have to distribute, so you're multiplying each term by 2, so that would give us 12x minus 4y equals, and on the other side, 2. So we're distributing that 2 3 times. And likewise, we're going to do the same exact thing. We're going to distribute that negative 6 3 times. So we'd have a negative 12x minus 18y equals, and now we get a positive 30. Okay, by multiplying that negative 6 by each piece. And you'll notice now here we have opposite coefficients. They're the same number, but one's positive, one's negative. Okay, likewise, we don't only have to do the x. We could say let's do it for y. So I'm going to take this first equation and multiply it by the coefficient of y, 2. I'm going to take the second equation and multiply it by the coefficient of y in the other one, but I'm also going to change the sign to negative. This was a positive 5, so I'm going to multiply it by negative, which leaves me with 8x plus 10y equals 70. I just distributed that 2 onto each term, and then I'm going to do the same thing on the bottom. So I'm going to say negative 5 times negative 3x is going to give me a positive 15x minus 10y equals, and now I get a positive 45. And you'll notice, same number, but different signs. One's a positive 10, one's a negative 10. So that's how we do step 1. If we go back and try that first one now from the beginning, so we said we're going to multiply this by 2 and our second one by a negative 6. So we'd end up with the equation 12x minus 4y equals 2, and our second equation was a negative 12x minus 18y equals a positive 30. And then step 2 was to add the two equations. So 12x minus 12x, 12x minus 12x, these two are going to cancel out, as they should. The second one, negative 4y minus 18y, is going to give us a negative 22y, and we'd end up with 32 when we add everything on that side. Dividing both sides by negative 22 then, so 32 divided by negative 22 is going to give us a negative 1.45, and that's okay. We can get a decimal, we can get a negative. So this was step 3 then. We solved for our y value. Now, we need to take either one of these equations. I'm just going to take that first one, 6x minus 2y equals 1, and I'm going to plug that y value in to that equation. So I'd end up with 6x minus 2 times a negative 1.45 equals 1. And I'm going to solve that equation. So 6x, if I say negative 2 times negative 1.45, I'm going to get a negative 2.9 equals 1. Add 2.9 to both sides, so I get 6x equals, this will be 3.9. Okay, and then divide by 6. So 3.9 divided by 6 is going to give me an x of 0.65. So my solution for this equation would be 0.65 negative 1.45, because remember, x always comes first, y always comes second. That would be our solution. Okay, so that is the elimination method. We're essentially making one variable disappear. We need to multiply both equations by something usually, so that one variable disappears. We solve for that remaining variable and then plug that variable back in to find our original one again. All right, we will see you next time.